All right, so graphing an absolute value inequality is the same as graphing an absolute value. However, now you're going to just shade inside or outside. So last week you took a graphing quiz on absolute values. So you know how to graph an absolute value. So let's talk about the transformations of an absolute value. If I were to make this table, what's being added or subtracted to my x? So -3. So what does that -3 tell me my graph does?
Goes down 3.
What's the 2 tell me?
Over 2.
2 to the
I
right
mean, up 2
1.
to the right one.
So that's my slope, right? My slope is 2/1. It's going to make my graph taller. It's going to stretch it. So my starting point is going to be at what point on the graph?
3. That's what I meant.
0, -3 is my vertex. So now from my vertex, I simply go up 2/1, up 2/1, up 2/1, or up to left 1, up to left 1, because remember, absolute values are symmetric. Is my line solid or dashed?
Solid.
Okay. What? Fine. What's your question? Yeah. Only if it was like a piecewise, which would be weird. Do you shade inside or outside the absolute value? So if you test point it, you test point 0, 0, and those would cancel. So you'd get 0 greater than or equal to -3. That is true, so you would shade inside. How about 8? What are the, or not 8, because yours is actually 5. What are the transformations in 5? Good? Good. So that's my new vertex, right? The left 2 tells me -2. The down 3 tells me -3. That's my vertex. That's what the downs and the lefts tell me. So left 2 and down 3. What is the slope? 1 to 1. So up 1, right 1, up 1, left 1, up 1, right 1, up 1, left 1, up 1, right 1, up 1, left 1. You continue your pattern. Solid or dashed? Is it equals to or not equals to? Good. So dash your absolute value together. Okay, in or out? So pick your test point. I don't care what test point you pick, just don't pick a number on the line. So you're like 0, 0. We got 0 is greater than 0 plus 2 minus 3. Is 0 greater than 2 minus 3? So where do I shade?
How are you?
What's wrong with Alexa? T-shirt black.
Turn error. All right. What I want you to do in the next 2 examples is I want you to change these equations to be y equals on your own. So take a minute and change the 2 equations so that they're y equals. Because the way they're written now, they're gruesome. You can't graph that. You got values all over the place. So what you want to do is you want to make it y equals mx plus b. Because the only thing that is different from graphing absolute values to graphing absolute value inequalities is that we shade them. So the best way to graph this is to solve for y. So what would I do to solve for my y? What's your first move? Yeah, subtract 3 from both sides. So now I have 2y is less than or equal to negative absolute value of x minus 5 minus 3. Do I like to leave a 2 on that y?
No.
So divide it by 2. And remember, you have to divide every individual addition or subtraction piece by 2. So I get y is less than or equal to, that's kind of like a negative 1/2. What's that negative 1/2 represent again? Yeah, it's my slope, right? Because I had to divide everything by 2 because of the 2 on the y. So instead of just having it over 2 like this, I brought it in as a fraction or a half. So you could see that my slope is down 1 and over 2. This negative 3/2 tells me what? Or just down 3.5. Because that's not a slope, that's the k value. The negative 5 tells me what? Yes. So what you do to graph your vertex is you go right 5 units. So instead of starting at 0, 0, I go right 5 and then down 3.5, which is 1.5. So you're going to be like in the middle of the 2 boxes. Or you could change your y values to be by half increments, but otherwise 3.5 is the same as 1.5. So your slope, when you do it, you still go down a whole block. So now instead of going down to like the next block corner, you're going to go down one whole block to the next half. So you're going to go down 1 and over 2. Down 1 over 2, down 1 over 2, down 1 over 2. Solid or dash? Pick a test point. So where are you going to pick it?
I don't.
Well, 0, 0 is fair.
Don't ever.
So test point 0, 0. So plug 0 in. So 2 times 0 plus 3 is less than or equal to negative the absolute value of 0 minus 5. What's 2 times 0?
0. Plus 3 is 3.
So is 3 less than or equal to, what's 0 minus 5?
Negative 5.
But it's inside an absolute value. But then there's a negative outside. So is 3 less than negative 5?
No.
No. So this is a false test point. So I picked 0, 0 as my test point, but it's false. So that means I shade inside the absolute value. So do you see how this is harder to follow? Because the test point of 0, 0 was inside and true. Because they were true. No. I picked, no. Ready? My test point of 0, 0 was false. That was no longer inside the absolute value. The absolute value is down below and open down. So that's why we don't shade where the test point is. It's December. It snows. So negative y plus 2 is less than the absolute value of x plus 3. What's my first move? Thank you. Negative y is less than the absolute value of x plus 3 minus 2. Can I start to graph it from here? No, why? What's wrong with it, Al? So divide by negative 1. Y is now positive. What happens when you divide by negative? You flip my sign. So you get negative the absolute value of x plus 3 minus plus 2, because it's a minus and minus. The negative tells you what happens to your absolute value graph. What's this negative do to your absolute value graph? Yeah, it opens it down. So that's called reflection. What's the plus 3 do? What's the plus 2?
Up 2.
Okay, so go left 3, up 2. Now my slope is negative 1 over 1, so it's down 1, right 1, down 1, right 1. And down 1, left 1, down 1, left 1. Solid or dashed?
Solid.
Dashed. In or out? If you put 0 in, you get 0 is greater than negative 0 plus 3 plus 2. So negative 3 plus 2, negative 1. 0 is greater.
Nice.
So it's outside the absolute value. That is